This movie is for geometry, properties of parallelograms. This is for learning target 3 and 4 of Unit 6. So we're going to be looking at parallelograms, and I'm actually going to skip this warm-up. You'll need your purple sheets out and your notes. The first essential understanding that we need to learn is that parallelograms have special properties regarding their sides, their angles, and the diagonals. Go to full screen. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So we have this side parallel to this side, and this side parallel to this side. In a quadrilateral, opposite sides do not share a vertex, and opposite angles do not share a side. So we've got angle B and angle D, which are opposite angles, do not share a side, and these two sides do not share angles. The last thing you need to know is that you can abbreviate parallelogram with this symbol. And parallelograms with this symbol with an S in it means parallelograms. It's plural. So you can use what you know about parallel lines and transversals to prove some theorems about parallelograms. The first thing you'll need to add to your purple sheet is Theorem 6.3. And when you go to your purple sheet, you'll see 6.3 on the front side of parallelograms. And you can write the theorem that's listed right here on the front side, and then also open it up, and you'll see 6.3 on the inside that says, if a quadrilateral is a parallelogram, then, and you'll fill in the rest of that opposite sides are congruent. So pause this movie, add it to your purple sheet, both on the front and on the second page, and then press play when you're ready. This is a proof for that theorem. As you can see right here, it involves congruent triangles. This is not something you'll be expected to do, but it is something, if you want to pause the movie just to refresh your brain on proofs, that can be helpful. Angles of a polygon that share a side are called consecutive angles. They're sort of in a row. In the diagram, A and B are consecutive angles because they share line segment AB. The theorem below shows the fact that the consecutive angles of a parallelogram are same side interior angles of parallel lines. If we look at this line, line AB and line DC, they're parallel. So if I look at line AD as a transversal, you can see that this angle, A, and this angle, D, are same side interior. And so therefore, they are supplementary. So I want you to pause the movie and add Theorem 6.4 both on the front side as well as on the inside. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Pause the movie and press play when you're finished adding that to your purple sheet. Using consecutive angles. What is the measure of angle P in parallelogram PQRS? So here's parallelogram PQRS. We have that angle S is 64. Let's find angle P. Knowing that it is a parallelogram, and we can see that here because it's listed there, opposite sides are parallel and consecutive angles are same side interior. So therefore they are supplementary. So I know that angle P and angle S need to add up to 180 because consecutive angles of a parallelogram are supplementary. I'm going to substitute angle S with 64, and then I'm going to solve for angle P by subtracting 64 on both sides. Angle P is then 116. So our correct answer is C. Another theorem that we're going to add, another property, is that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if I'm looking at this, if ABCD is a parallelogram, then A is congruent to C, and B is congruent to D. Pause the movie, add it both to the front side and the inside of your purple packet, and press play when you're finished. There is a proof for this. given the parallelogram, proving those opposite angles congruent. You can look over that proof if you like, not something you will need to produce on your own. We are going to skip this proof as well. And I would like you to add this theorem to your purple sheet. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So here I've got a parallelogram. Diagonal BD will bisect diagonal AC, cutting it in half. That does not mean that BE is congruent to AE, but it does mean that BE is congruent to ED. Pause the movie, add to your purple packet, press play when you're finished. We're going to use algebra to do this one. Knowing that this one is a parallelogram KLMN, we know that LP is congruent to PN, so X is equal to Y plus 2. And we know these two are equal to each other. So what I end up getting is a system of equations where I've got two equations with two variables. And so there's many ways to solve a system of equations, but once you set up your system, what we're going to take is, here I have y plus 10 equals 2x minus 8. I'm going to substitute y plus 2, which is right here, in for the x right there. This thing keeps going where it wants to go. So I'm using substitution. X is equal to y plus 2. So I'm taking y plus 2 and plugging it in for x here. So I get y plus 10 equals 2 times, instead of the x, I'm plugging it in with y plus 2 minus 8. I'm going to distribute that 2 in. Gives me 2y plus 4. I'm going to add my like terms. 4 plus negative 8 is negative 4. Get the numbers and the variables on the same side. Here I subtracted y on both sides. Then I'm going to add 4, and I get that y is 14. Now I know that y is 14. I can plug it back into one of my originals, 14 plus 2, and get what x is. X is 16. So now I know that y is 14, x is 16. I can plug it back in to get that the length of km is 2 times y plus 10. So I get km is 48, and I get ln is 32, just by plugging it back in. So using substitution or a system of equations to solve is another way to do this. Let's apply it to this situation. Here we're given parallelogram PQRS at the right. I want you to find the lengths of PR and SQ, and then I want you to pause the movie and write them down, because at the end of this movie there will be 2 questions that I'm going to ask you, and I want you to input your answer to this one just so I can check that you've completed this movie. So pause the movie, write your answers down. What is the value of x? What is the value of y? Then I want you to find what PR and SQ are. You do not need to do part B, but just find part A, pause the movie, write those down, and then continue the movie. Theorem 6.7 says that if I have 3 or more parallel lines, cut off congruent segments on one transversal, then they're going to cut off congruent segments on every transversal that goes through the parallel lines. So if line AB, CD, and EF are parallel, and I have that AC is congruent to CE, then I know that BD is going to be congruent to DF. It's going to cut every transversal into congruent line segments. Pause the movie, add this to your purple sheet. Press play when you're finished. Okay? Using parallel lines and transversals. In this figure above, we know that AE, line AE is parallel to line BF, so on and so forth. If AB is congruent to BC, or equal to BC, and BC is equal to CD, and they're all equal to the value of 2, EF is 2.25. What would be EH? So since we know that the other transversals cut into congruent line segments, then I know that EF is going to be congruent to FG, is going to be congruent to GH. So they're all going to be 2.25. So if I want to know what EH is, I would add those together to get 6.75. In this figure, I want you to find what CD is, the length of CD. Go ahead and pause the movie and write your answer to this question down. This is going to be the second question that I'm going to ask you to input at the end of this movie. And that is all for the movie. Please answer the 2 questions, and then that will be all for your homework.